late today. It'll be later today, but it'll get done. Okay. I did, I think, hit record. Yes, I am recording. So Miss Rondo, you're going to take it away this morning?
Yes.
You said you were going to start.
All right. We're going to jump back and forth a little bit between us, but yes, I'm going to start. And hopefully I will pick up well from where you guys left off, because
all they know from Friday is how to do this from the triangles. So
okay. There's some other bits and pieces. So if I'm repetitive and you guys are like, yeah, we already know this, don't mind me. I'm just going to try to be really
okay. We could use the repetition right now.
That's right. Really elaborate. All right. So we should be on, on page 257 in your notebook, I believe. And at the top, you have a couple of pictures. The first one here is the unit circle that you guys should have talked about on Friday a little bit. Comes from the equation of a circle. And the big important thing is that the radius always equals 1 when we're talking the unit circle. You also should have talked about the coordinates for some of the major angles, the 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then those ordered pairs representing ordered pairs on a graph. Hopefully, and you should have already talked about this.
Probably didn't get into that as much on the ordered pairs, so you can go through that.
Okay. I'm not sure exactly what you mean, Mrs. Ballard, but I'm going to keep going and just jump in.
I didn't overemphasize it other than on like, hey, if you get one that's on the coordinates, use the coordinates. If it's not on the coordinates, then use the chart. And then if it's not on the chart, then use the triangles.
Gotcha. Okay. So basically what Mrs. Ballard and I are talking back and forth about is these coordinate angles or quadrant angles, quadrant angles, 0, pi over 2, pi, 3 pi over 2, and 2 pi. They're called quadrant angles because they land on an axis that separates your quadrants. When you have one of those quadrant angles, you're going to use the fact that we know our ordered pairs, the 1, 0, 0, 1, all those lovelies. They're x and y values, but they also are cosine and sine. So when I look at this, for example, if I asked you guys to, I'm going to ask you a question here. Here we go, right off the top. If I wanted to know what is the sine of 0, actually, I won't ask you this one. We'll show you how, and then I'll ask you a different one. That'll probably be a little better. So I go to 0. The ordered pair at 0 is 1, 0. And the sine, I know, represents a y value. So the sine of 0, I'm going to literally look at the y value for that ordered pair, and that's my answer. So sine of 0 is 0. So now I want you guys to try, see if you can pop this into your answers. I want the cosine of pi. What would the cosine of pi be?
So everybody put that in the chat, cosine of pi. Nothing yet. And not everybody was here on Friday.
Okay.
Still waiting. Oh, we got one. -1, Fallon says. Negative. Oh, we're getting a whole bunch of -1s.
Fantastic. So maybe we have.
Know it.
Yes. So at pi, our ordered pair is -1, 0. Cosine represents an x value. So we want the x value, which would be -1. So that's kind of, that's actually an important thing to know those quadrant angles. And you can set that up really quickly by drawing yourself a circle. And then we know the unit circle, the radius is always 1. So this distance from the center to the outside is always 1. So your units that you put for your ordered pairs are always going to be some version of 1, whether it's +1, -1, depending what direction you're going. So those should be pretty straightforward. Anything else you want to add, Mrs. Ballard, before I go on?
Nope, keep going.
Awesome. Let's move on. All right. So then we have this picture. Each value on the unit circle corresponds to a set of coordinates, an x value and a y value, which we know as sine and cosine. I'll give you a second to jot that down in your notebook. This is what you should be writing right above those pictures. And I know these pictures are not great, but they kind of give us the idea. We're going to be looking at everything on a graph. So our unit circle is always going to be on a graph in reference to the coordinate plane. And again, X and Y correspond to cosine and sine. All right, so let's take a look. This says determine the exact value of the 6 trig functions of the angle theta. So I want to remind, hopefully from Friday, but if not, when we have our angle theta here, we always draw our reference angle and triangle to the x-axis. So this is my terminal side right here. But I'm going to draw my triangle, always drawing my altitude to the x-axis. So that's my reference. And my reference angle is right in here. So even though this is the angle theta that's marked there, the reference angle that we build our triangle from is always here. It's not a super big deal for this one, but what we are looking at is we have the point right there that is given to us as -4/5 and 3/5. And we're supposed to find the 6 trig functions. We're going to use the fact that we know that this is cosine and sine to help us out. So I'm going to start with my generic, my first 3. So I'm going to say sine of theta. And I jump over there and it tells me the y value is 3/5. Literally from the ordered pair. Then I'm going to do cosine. Cosine is the x value, so that's -4/5. And then I'm going to do tangent, which Mrs. Ballard, did you guys talk about tangent?
Yes, we did talk about tangent in the context of, we did it based off the triangles, but we did it in the context of just the quadrant angles. So they know a little bit about that.
Okay, so I just jotted it down on the side here. We're mentioning that cosine is the x, sine is the y. The tangent equals y/x, or we could say sine over cosine. We'll talk more about that one as we continue through, but that's a quick reference for you that that's tangent. So here, when I go to figure out tangent, I'm going to literally set up y/x or sine over cosine. So that's 3/5 over -4/5. So here, there's a property we use when we divide fractions that instead of dividing, we multiply by the reciprocal. So this problem would be 3/5 times the reciprocal, which would be 5/-4. When we do that, you can see these 5s are going to cancel out. So as a shortcut, when you have 2 fractions that are divided by, they have the same denominator, our shortcut is actually to cross those out. And if you see, what we get here is 3/-4. In my little problem down here where I did multiply by the reciprocal, I still get 3/-4. It's kind of a handy shortcut there if you can remember it. Then I'm going to go through and do my reciprocal functions. So I have cosecant would be 5/3. My secant would be 5/-4. And remember, with negatives and fractions, even though literally it would be 5/-4, that negative could be just in front of your fraction, or it could go to the top depending on your purpose. So that negative is top, bottom, or in front, depending on what you're doing. All right, my last one, I'm going to pop down here to the bottom. Cotangent would be -4/3. Any questions before I go on? Silence, sounds good.
Don't have anything in the chat.
Fabulous, let me know. Okay, so we're going to do the same thing again. I'm going to remind us that even though theta is this whole big angle, the reference angle is always from that terminal side to the x-axis. So this is our reference angle. It's also where we would draw our triangle, whoopsie, is going to be always an altitude to the x-axis. So it doesn't matter where your terminal side is, you're always going to draw that to the x-axis. There's our triangle. We're not really using the triangles for these problems, but just a good reminder. So here's our ordered pair for this point. And we're once again, remember that this is cosine sine. And we also have tangent of an angle is the sine over, whoopsie, come on, honey, sine over cosine. Come on, honey, there. Okay, so we're going to go through and build these. I'm going to start with sine. Sine is the y value, so it would be 12/13. Then I have cosine. That's the x value, so -5/13. Then I have tangent. And here's where we get to use that super cool trick. I'm going to do sine over cosine. And since they're divided by the same thing, I'm just going to cross it out and say, hey, the answer here is 12 over negative 5. Then I'm going to go through, we're doing all 6 trig functions, so I'm going to flip them all. Let's do cosecant of theta is 13 over 12. Secant of theta is 13 over negative 5. And down here at the bottom, cotangent is going to be negative 5 over 12. And that gets us through our first 2. The next ones, we're going to be talking about the unit circle, and Mrs. Ballard is going to jump in here and help us out with a way that we can memorize the unit circle. That's really super handy when you're in calc. So I'm going to hand that to her because
yep, I am going to share my screen. All right. All right, so you guys should be seeing me now. So Friday, we kind of built out this unit circle. So you should be familiar with that. We will again, like I told you on Friday, we're going to build one of these so you have it. But there's another whole layer to this. Friday, we came at this from the perspective of we're going to do the base it off the triangles, either drawn or we color or using the color-coded triangles. But we don't do that when we come at it from the calculus perspective. We typically work with radians. Oh, it didn't do my animations. That's a bummer.
Ah,
I know my animations didn't go. I don't know why they're not going. I don't know if it's just this machine or if it's.
yeah, because it should be.
Yeah, it should be animating. I thought it was on this one. Okay, well, I'll do this a different way then. Okay, I'm just gonna handwrite it out.
That's what I was going to say. Do you have a blank one that you could?
Yeah, I'm just gonna.
Where's Andy for the joke of the day? Why we pop it in?
I know. Andy, come do the joke of the day. I have a blank somewhere.
I just saw it. It was in.
Yeah, I got it. It's there. Actually, if I do the PDF, then I can just go to. Yep. You didn't.
You guys for your patience, but this is important. Hopefully, you guys got this printed ahead of time.
If you got this printed, that would be awesome. If you didn't, it's okay because you can just sketch it really quick somewhere on a piece of paper. I'm gonna put it into there and put it into there and click OK. Okay, let's see. There we go. Okay, so I've got my printout. We'll get Andy back in here eventually.
No worries.
Okay, so here's my printout. So first thing I'm going to do is I'm going to add my. We'll do the fancy and just give you something to look forward to next year. We'll do the fancy animated one in calculus next year. So I'm going to start with filling in my my radian measures, and I'm going to pull up my cheat sheet here so that I don't mess up my radian measures. Okay. And I'm going to only do radians, not degrees. Okay. So for this, we typically just stick with the radians. So I've got 0 radians, and then I know my next one is, we could count them off just like we did last week. So let's do the pi over 4. So this would be 1 pi over 4. This one's 2 pi over 4, but we like to call it, reduce it to pi over 2. This one is 3 pi over 4. This one is 4 pi over 4, which we reduce to pi. 5 pi over 4. 6 pi over 4, which we reduce to 3 pi over 2. And then 7 pi over 4, and then this one again would be 8 pi over 4, 2 pi. If you're just drawing this by hand, all you have to do is draw this, right? And then draw draw those angles in first, okay? And then we're going to add a layer on where we're going to draw in all of these angles, which did not go well.
I'm glad to know I'm not the only one.
Yeah. So I'm going to now add in my other layer of angles. So I'm going to do my pi over 6s, which will also take care of my pi over 3s. So this is 1 pi over 6. This is 2 pi over 6, which we reduce to pi over 3. Technically, this is, and then it goes 2 pi over 6. 3 pi over 6 would be here, which is pi over 2. 4 pi over 6, which reduces to 2 pi over 3. 5 pi over 6. This one's 6 pi over 6. 7 pi over 6. 8 pi over 6, which would be 4 pi over 3. 9 pi over 6 would be that one, which is reduced already. 10 pi over 6 would be 5 pi over 3. And then 8 pi, so sorry, 10 pi, 11 pi over 6. And then 12 pi over 6 is 2 pi. All right, so we're going to make this as easy as 1, 2, 3. That's what you got to remember. So I'm going to start by writing in my quadrant angle coordinates. So I'm going to count out 1 and up 0. And this is going to seem totally bizarre, you guys, when we're doing this, but it'll make sense if you just kind of go with it. So that one's out 1, up 0. This one is out 0, up 1. Okay, and then this one is out -1, up 0. And this one is down 0, out 0, down 1. One way a student many years ago remembered this, and I don't like this at all, because he remembered it like not as a coordinate. He thought that this looked like a -10 and this looked like a +10, and that's how he remembered it. If that helps you, great. If not, it's okay. All right? I would prefer you think of it as a coordinate, but I mention it only because sometimes it helps. All right, so you got to grab the coordinate that is the 0, and we're going to count up from that coordinate. So I'm going to go from this 0, and I'm going to count up 1, 2, 3. Whoa, that was nice. Let's try that again. And then from this coordinate, the 0 is in the x coordinate, and I'm going to count down 1, 2, 3. Then I'm going to divide everything by 2. All right, and then I put a square root over everything, but a square root of 1 is just 1, so I don't use the square root over that one. And what we're creating is actually the same coordinates we would get as if they were on the triangle when we were doing the triangle method on Friday. This is just a shortcut. Okay? And then we're going to go ahead and do the same coordinates. So that's the quadrant 1's coordinates. Quadrant 2, I'm starting with the 0 and the x, so I count down 1, 2, 3. And then the 0 from the y, and I count up 1, 2, 3. I divide everything by 2. And then we put a square root over the top of everything. The ones, we know the square root of 1 is just 1. Then, I remember how we learned all students take calculus on Friday. Okay?
That's right, all students.
That's right, everybody takes calculus. All right, so remember that the sine coordinate or the cosecant coordinate is going to be negative or positive in quadrant 2. So the cosine we know is the x coordinate if the cosine's negative. All right, I'm going to do this again. Easy as 1, 2, 3. So I'm going to count from the y coordinate is 0, so I'm going to count down 1, 2, 3. This one, the x coordinate is 0. I'm counting up 1, 2, 3. And then I'm going to divide everything by 2. And we're going to count, or I'm going to put square roots over everything. And in quadrant 3, tangent is positive, so that means both sine and cosine are negative. All right, and then I'm in the x coordinate for the this one here, so I'm going to count up 1, 2, 3. I'm in the y coordinate here, so I'm counting down 1, 2, 3. Divide everything by 2. Square root everything. And then in this quadrant, we know cosine is positive, so that means that the sine coordinate has to be negative. So I'm going to show you really quick the relationship that we had on Friday. I'm going to go with a 45, 45, 90 right triangle because I know that one really easy and I won't mess it up. So if I was asking you to find, because we know, hopefully we figured out that pi over 4 is the same as 45 degrees. So we would use this 45-degree triangle. If I was going to find the sine, because I want you to believe those relationships, the sine of 45 or the sine of pi over 4, they're the same place. If I looked at the triangle, I would use opposite and hypotenuse. So my opposite is the square root of 2, and my hypotenuse is 1. Something's not turning out, is it, Miss Rondo? Did I mess something up? Oh, yes, I did. What did I do with my triangle, Miss Rondo? That was terrible.
Are you doing pi over 4?
I'm doing pi over 4, and I should have had 1s here and square root of 2 there. Now I'm all better. Okay.
Unless you were, sorry, I assumed you were doing unit circle, but that still would have been a different.
Yeah, I was
would have been different.
Relationship between the triangle and the unit circle. So I'm good now. All right. So
all better.
If I was going to do the triangle, I know my opposite is 1 and my hypotenuse is square root of 2, which we wouldn't like to leave it like that. We would say, hey, you got to rationalize that. So it'd be square root of 2 over 2. And if you notice, that value we got off the triangle is the same as this y value right here. So the unit circle layer, doing it with the coordinates, is a shortcut to the triangles. Your homework's going to look really similar tonight to what it did on Friday, because but you get to use the coordinates tonight if you'd like. Okay. All right. I'm going to let Miss Rondeau take over from there. We have that hopefully written down. Do we have any questions or anything, Miss Rondeau?
No, the last thing was what page we're on, but we got that solved. So
yep.
But students took care of each other. They're awesome.
I guess they did, because I wasn't watching, and I wouldn't have known what page we were on because I wasn't paying attention.
No worries. All right, so I'm going to jump back to where we were somewhat. So there, I'm going to put this back for a second. This is what Mrs. Ballard just created for us again, and I'm going to ask you guys to reference this. So hopefully you guys have it printed out, but if not, I have it here and we can jump back to it in just a second. All right, so now we're going to find the point xy on the unit circle that corresponds to this. This is kind of going to act like our angle. So here this first one, I'm going to draw it to kind of, again, make that connection. And then we're going to definitely reference using the unit circle, because that's kind of the point, is to be able to use the unit circle. But I'm going to start with this one drawing. So I would do my 0, pi, 2 pi. And then I'm dividing pi into 3 sections. So there's my 3 sections. And then 3 sections on the bottom, and I'm looking for the second piece. So my angle would be 1, 2. This would be my 2 pi over 3. And as I mentioned, this is always going to be on a graph. So there's my y-axis. It wasn't one of my counting lines, but it's still there. And I'm going to build my triangle, always draw that altitude to the x-axis. And then I have my reference angle that's inside my triangle. And this is something Miss Ballard mentioned, and I want to make sure it's really clear. The reference angle is basically what you're dividing pi by. So my reference angle is pi over 3. In degrees, quick question, what is that in degrees?
So everybody in the chat, put what is pi over 3 in degrees?
Sounds like a very exciting chat right now.
It is. I know there's a little bit of a delay.
That's okay.
I wonder how many my students answered versus how many of yours.
The last I counted while you were going, and it was like, I kept counting 13 and 12, I think, but that didn't add up to 28 individuals. So apparently I can't count. I don't know.
And I think sometimes when you're presenting, one person's presenting, it pops an extra person in there maybe.
Okay, then it might be that. So we were pretty close.
Who would answer in the chat more, mine or yours? Right now, they're saying 60 degrees.
That is correct. It is 60 because
I have 1 in the chat, and you have 3 in the chat that answered 60.
Woohoo! Good job, Rondo. So remember, pi represents 180 degrees. So if you take 180 divide by 3, we're talking 60 degrees. So this is helpful to remember. Pi over 3 is the world of a 60-degree angle. So this is really a 30, 60, 90 triangle. And hopefully we remember the story of the 3 bears. Very important, of course. And for my story of the 3 bears, since we're talking unit circle, that's telling me that my hypotenuse is 1. And we hopefully remember, excuse me, that Papa Bear is twice as big as Baby Bear. So if Papa Bear is 1, then Baby Bear would have to be 1/2. And remember, Baby Bear is the short leg or across from the 30-degree angle. And then to get to Mama Bear, we would multiply by the square root of 3, and that would give us root 3 over 2. Now, there is a problem. So those those are all good and fine and dandy, correct measurements of length. However, we are on a graph and I'm trying to get to this point right here. So I'm using my triangle to help me get to that point to describe how many I go over and how many I go up. So we're trying to build X and Y. So my X is this number down here, but on a graph, I would say this is negative 1/2 because I went left. So when I build my ordered pair, this is negative 1/2, and then I go up √3/2. So even though the distance for the length of the side of the triangle would be 1/2, because we're on a graph, the location matters, it would be a negative 1/2. So that's the connection to your triangles. Then we're going to do, oh, we just wanted the point. I'm sorry, I thought we were doing trig functions. Just kidding. We got the point on the unit circle that corresponds to that angle. All right, so I'm going to have us check that. So I'm going to actually go back. We were looking at 2π/3. Let's see if we got it right. We go back to this, find 2π/3. Did our point match the unit circle? It did. So we are good to go.
Looks good to me.
What's that?
It looks good to me.
Fantastic. So we're going to come back and use this to reference. So rather than drawing the triangle every single time, which you can, if you want to draw the triangle, I am a big proponent of draw it. It doesn't have to be a detailed sketch, just quick to give you your bearings, but you don't have to. So when we go to this one, we're going to try it with the unit circle. We're going to look at t equals negative π/4. So this one, I'm going to actually show it on the unit circle. We want to go negative π/4. If I look at my measurements here, none of these say negative π/4. So if you recall, negative angles mean we start at 0 or 2π and we go backwards. So if I go back 1 π/4 angle, that actually takes me to 7 π/4. Any questions there before I go on? Any clarification, Mrs. Ballard?
I think you're good.
Okay. Then from
I know I talked about that on Friday a little bit.
Perfect. Then all we're looking for is what is the coordinate? What are the coordinates? The X and Y, and we can see them right there. √2/2, comma, negative √2/2. I'm going to scoot forward again. So our answer here would be √2/2, negative √2/2. So this is why having that unit circle memorized is super handy because you can save yourself a lot of time. All right, this one, same thing, find the point on the unit circle, 5π/6. This one I'm going to, whoopsie, go the wrong direction. It was 5π/6, right? I think so. So here's, that's all right. I'm pretty sure it is 5π/6. Here it is over in quadrant 2. And I'm going to match up. Here's my coordinate that I'm going to steal, my ordered pair, negative √3/2 and 1/2. So I have negative √3/2 and 1/2. Fantastic. All right, then we're going to change directions a little bit, going back to the trig functions. Evaluate sine, cosine, and tangent of the real number π/6. So this one, again, just a reminder that we can use the unit circle to help us out. You can draw it if you want and build your triangle. We would divide pi into 6 pieces. And π/6 is the first one. So here's my triangle. And this is a 30, 60, 90 because π/6 is 30 degrees. So I'm doing it very, very fast at this point because you guys should have this. If you're drawing the triangle, it should be fast. If it is not fast for you, if you can't get that, then you need to work on memorizing the unit circle. You need to do whatever will work the quickest for you because we don't want to spend all our time just drawing triangles. So this one would be my hypotenuse is 1, 1/2, and √3/2. Double check location. I'm in quadrant 1, so both of those would be positive. There's my ordered pair. This time I'm asked for the trig functions though. So if I wasn't doing the triangles, if I wasn't drawing it, I would jump over here and I would get the same ordered pair. There's π/6. I get √3/2 and 1/2. So matching answers. But that helps me to quickly build sine. Actually, I don't need to call it theta because we know it's π/6. Excuse me. All right, so sine of π/6 would be the y value, 1/2. Remember, x and y. This is cosine and sine. And then cosine pi over 6 would be root 3 over 2. So those two are the ones that are really straightforward. Then tangent's the one that's a little bit harder because you have to use both of them. So this would be y over x or sine over cosine. So sine over cosine, and we can use that nifty trick. If my fractions are both the same denominators, I can cross them out and I get 1 over root 3. But of course, if you write that as your answer, Mrs. Ballard and I will both be very angry. No, we won't be angry, but we will not like this. This is not a rationalized answer. So we'll fix it up, multiply top and bottom by square root of 3, and we get root 3 over 3. And that is where I'm going to leave you guys off to Mrs. Ballard.
Awesome. All right. So let me get my notes back up here.
I'm not quite not sharing my screen. There you go. Now you should be good.
There you go. Okay. So I get to do a little bit more with the, let me share my screen. And Ms. Rondo, I was kind of working on it while you were teaching. Oh, wait. Andy, come here, quick.
Joke of the day.
We need joke of the day. Hold on. Before I share my screen, we'll put Andy up here. All right. Andy, joke of the day. What is it?
How do you get warm in an empty room?
How do you get warm in an empty room? I don't know how to get warm in an empty room.
Stand in the corner. It's always 90 degrees.
Oh, even a math joke. Good job. All right, go work on your homework. No piano yet. Not till I'm done teaching the class.
Bye-bye.
Bye. All right. So I am going to. Oh, so while I was I'm totally not sharing my screen yet, am I?
Nope, that's okay though.
All right, here we go. While you were teaching, Miss Rundell, I was able to get the videos sent to you. So, nice. And there's also a new Delta math assignment out there you could grab. And for my students, because I know a couple of you guys are asking, I did put it out. The videos are now in PowerSchool. So I'm just going to see if I can really quick grab a picture here from a file, which I'm sorry I did not have this set up ahead of time. I was doing it kind of like a talking collaboration. It was in there.
While you're doing that, just to clarify for Mrs. Ballard said for her students, it's in PowerSchool. If you guys haven't been on PowerSchool, all the videos thus far, except for I think the last two, so from Thursday and Friday of last week, those are the only ones that aren't there that apparently Mrs. Ballard just sent them to me. So I will post them for you. And it's just our live session and I'll make sure all the answer keys are up and stuff. So check PowerSchool. It'll be done today.
All right, here we go. We're now cooking with gas. So I am starting with example 7 here. And I apologize, you're gonna see my ceiling. Or hopefully not up my nose. All right, we're going to evaluate the 6 trig functions again, and I'm going to come solely from the unit circle perspective because that's kind of how we roll in calculus. So I always teach it from that perspective, which Ms. Rondeau's perspective is great. If you know it that way, do it just like she said. But this is just the way I end up doing it. So I'm supposed to find.
Oh, sorry, just to clarify, that is where, even though I teach it from the drawing the triangles, that's so that we know where it comes from and it always works. But you really need to get fluent and be able to do unit circle.
Yep, absolutely. And I really appreciate that it comes from that. We want to make that connection that it comes, this all was based off of right triangles. So, we are going to start, we're going to do all the trig functions from pi over 4. So I'm using, remember the x coordinate is the cosine and the y coordinate is the sine. So, ooh, that's not what I wanted to touch. There we go. Okay, go back there. All right, so I'm going to start with the sine of 5 pi over 4. I know that 5 pi over 4 is this y coordinate, so it's negative square root of 2 over 2. What I will typically do is I will go ahead and do its reciprocal at the same time. So I'm going to do the cosecant of 5 pi over 4, which I do need to flip this, and there's going to be some stuff you're going to learn about this that you're going to see patterns really quickly on this. I have to rationalize it. So that means I now have negative square root of 2 I feel like something's going wrong. No, I'm doing fine. All right. Negative square root of 2 over square root of 2 times square root of 2 is, oh, I know what's going wrong. I didn't put my 2 on the top, did I? It's right there. Now we're going. All right, so negative 2 square root of 2 over the square root of 2 times the square root of 2 is just 2. So we can see that these will cancel, and I just get negative square root of 2. You're going to probably start recognizing the reciprocal of this one really easily soon, that it's just negative square root of 2. All right, I'm going to keep going. So now cosine, I'm going to read the cosine out of there. So the cosine of 5 pi over 4, when I read that coordinate off the graph, is negative square root of 2 over 2. And I'm going to do its reciprocal secant the same time, which is negative 2 over square root of 2. And you'll notice it was the same as this one, so I really don't need to go through all this again. I can just write down that it's equal to negative square root of 2. And then finally, we want to do tangent. So the tangent of 5 pi over 4, remember we learned on Friday, it's the sine over the cosine. So I'm going to take the sine coordinate and divide it by the cosine coordinate. Negative square root of 2 over 2 divided by negative square root of 2 over 2, which hopefully you recognize that that is just 1. And then the reciprocal, the cotangent, would just be the reciprocal of 1, which is 1. We doing okay in the chat, Miss Rondo?
Doing great. Everything looks good.
All right. So 8 and 9 differ a little bit in the fact that they are not on our unit circle. And I'm going to erase my scribbles on here so that we can scribble on it again. So I need to figure out where they are first. So I'm gonna come at it from add and subtract 2 pi. We could also count this like we were counting the wedges last week, but I keep flipping back and forth because I'm not able. I'm sitting
Really
on the
like
sofa
that
today,
unit circle.
and it is just flipping out on me all over the place. All right, so we're gonna subtract 2 pi. In an over 3 world, we've learned that 2 pi is 6 pi over 3. So that means that the sine is really 5. It's really, we're looking for basically the reference angle of 5 pi over 3. So that would be my terminal side. So I'm going to find 5 pi over 3 on my unit circle, which is right here. And this time they're not asking for all 6, they're only asking for sine. Sine is the y coordinate, so I'm just going to grab the y coordinate from right there, which is negative square root of 3 over 2. And a handy tip that I always try to remind my students on sine and cosine, cosine is first alphabetically and sine is second alphabetically. So x is first alphabetically, y is second alphabetically. So they're in alphabetical order every time. All
amazing.
Right. Isn't that amazing? I wonder if, I don't know who did trigonometry. I don't know which mathematician. Euclid probably had something to do with it somewhere.
Probably.
And maybe Pythagoras. So I wonder whose genius that was. But they did it in Greek, so who knows who did it and who translated it to English. All right. In this case, I have a negative 5 pi over 4. And again, I could count that on my unit circle, or I could just add 2 pi. So I'm going to choose to add 2 pi. And I'm going to do, and we know in over 4 world, 2 pi is 8 pi over 4. So I know that this is coterminal with 3 pi over 4. So I'm going to find 3 pi over 4 in my unit circle. Cosine is the x coordinate. So my x coordinate is negative square root of 2 over 2. And I'm done. I don't have to do anything else. Then the next piece of this is we're going to talk about even and odd functions. Okay. I don't know. I know that Mr. Rondo might not have had them up yet because we hadn't quite gotten that far in the year. But we had, if you were in my classroom, and I know you've all been in my classroom at some point, because I know that we've taught a few lessons over there. But there's been some colorful signs above the windows in my classroom, if you can kind of envision that. And those are what we call the trig identities. And these are kind of some of the beginnings of the trig identities. So some of these were up on the wall. So these are things you're just going to have to take our word for it, because we're not going to prove them with you. They're like formulas. So if I have the cosine of negative t, it's also equivalent to the cosine of t. Notice the negative sign kind of just disappears, and that's because it's actually an even function. We're not going to get into what it means to be even and odd. Just know that this is a property. Okay. And
Well,
then
Mrs. Ballard, even though I agree with you, don't want to get into it too much. Even functions would be kind of like doing a parabola. When you take something like y equals x squared, if you plug a negative number in, you get a positive answer.
Yeah.
If you plug a positive number in, you get a positive answer. That's kind of how even functions work. They work a lot like y equals x squared.
Yeah.
That helps.
And I just drew pictures of an even and an odd function. So just a little refresher. And I know I had that on my notes and I should have gone there.
No worries.
An odd function, so an even function will go positive, whereas an odd function will stay negative. And the way you want to think about these is this negative sign. The way I think about it is it kind of floats out in front. So it'll be negative sine of t, negative tangent of t, negative cosecant of t, and negative cotangent of t. And I know my cosecant looks terrible. Gotta fix that. Okay, so all we're going to do on these last few, and this is more of an expose you to it versus there's not going to be a ton of homework on this. This unit circle stuff up here at the top, that's way more important than this. Okay,
absolutely.
So this is a good, let's just kind of see how this works. And we're not going to do 12, 13, 14 because we are not going to mess with calculators. So we get to cross those ones out today to end early. All right, so first, I'm going to apply the property to this because I know that we're supposed to use the indicated value to evaluate this function, but I'm going to apply that negative because I don't have a negative inside here. So to take the negative out, I know it's an odd function. So I'm going to pull the negative out in front of the sign. And then I know sine t is equivalent to 1/5, so I'm going to substitute that in. So it'd be negative 1/5. Cosecant, again, I'm going to have that negative on the inside, and it's an odd function, so I pull it to the outside. I don't know what I wrote there. So equals negative, and I'm going to negative cosecant of t. I know that cosecant is the reciprocal of sine, so I'm going to actually draw the reciprocal of that. So it'd be negative 5/1. And it's up to you. I don't care about the over 1 in the denominator. That doesn't bother me. But you can write it as just negative 5. All right, I'm going to look at the next, example 11. So cosine of 5/3, we've got the cosine of negative t. And we know that when an even function, the cosine just goes away, or the negative just goes away. And I literally get to just replace it with 5/3. Secant, again, is an even function. So I know that the negative on the inside is going to go away. So I just get secant of t. And then I'm going to do, for secant, I know it's the reciprocal of cosine, so I'm going to flip it, and it is 3/5. And that is all we've got for today, Ms. Rondo. That one went a lot quicker.
It went very fast.
This is going so much quicker virtually than it does in the classroom.
Right?
Probably because we're not stopping and giving a test.
No, we're not.
Normally, we would have stopped you after Friday's lesson and given a test, but we're just going to keep moving. Our goal is to just teach the content right now. And your kind of assessment on it is doing your homework and trying the homework assignment and seeing if you can get it right. And you're only getting enrichment at this point. And I did talk Miss Rondeau into points for showing up every day.
She twisted my arm. It was really tough.
It was tough. It took me all about 30 seconds.
Yeah.
I don't know what. I'm looking back at the text message string, Miss Rondeau. We decided on 25 points a day. Was that right?
Yes, 25
points. And if you come every day of the week, you get bonus points.
That was my idea.
Yes, Miss Rondeau added the bonus points in. She had to twist my arm for about 30 more seconds to get that done. Right. So we are giving you guys bonus points. Hang on, I got to don't go anywhere, guys. I got to take a picture of roll yet. I haven't done that yet. Just to make sure. Did you count how many we ended up having? Who won?
You won by 1.
Good job, Ballard's class.
Whatever.
All right, Ballard's class. See if you can get 2 more people here tomorrow, okay? All right. Ashley, I don't know how much is going to increase the grade right now. I know some of you that are coming have A's already, which is great. And we're going to make sure it does increase your grade no matter what it does. So
It will only increase. We're not
only increase. We're not doing any decreases of grade. So I don't know what it's going to act in there like, because I think we decided to put it into, we said notes, right? Or organization. So
Right.
it'll give you a little bit of a bump. But we do appreciate you guys coming every day. So we really like teaching too, even though they're little just dots on the screen. We really enjoy teaching to you guys. So
yeah. Well, and we really, I hope that it's clear from both of us, if you ask, you shall receive. So you guys are asking for points. We're on your side. We want you guys to do well. We want, you know, things to be good. And part of the reason that we're doing full-on lessons is because we want you to be successful in calculus. And this is really important content that you need going into calc. So.
All right.